Hi, I'm Nilo Monteiro from the Federal University of Espírito Santo in Brazil, and I will present my paper explaining vibration patterns and fault diagnosis in the oil industry via Finetuned Chatbot. This research was developed in our laboratory in collaboration with a multi-million enterprise in the oil and gas industry in Brazil. Essentially, our work is to research the fault diagnosis problem in the oil and gas industry. This process is usually done by visualizing several vibration patterns extracted from the components of each electro-submersible pump, which is an equipment used in offshore production. This is usually done by experts in the field. However, our previous research has led to the development of a software which can make this process easier. The software provides machine learning algorithms that can automatically label signals based on some feature defined by these specialists. However, for users that are unfamiliar to this domain, the diagnosis process becomes harder to follow, as it requires knowledge of what to look for in the data. For example, given a signal, what should I look for in the data? What fault is it, and what gives it away? Thus, how can we explain this to the user in a more natural way, and how can it be more interactive? In an attempt to tackle these issues, we have utilized the interactive abilities of a large language model and provided it with a synthetic textual dataset which contains information about the signal's visual characteristics and expected labels. Features are defined and extracted from the data in the frequency domain. Feature values are discretized based on thresholds observed by specialists. Then synthetic signals are created to better populate each level. And all signals are used to generate the textual dataset by filling description templates. Later, the values of each feature are processed in order to better distribute the data, and the values and conversations are passed to the LLM for the fine-tuning process. Asking the chatbot to describe the signal. And it returns a complete description. Asking about the fault in the signal. And it provides the label and some reasoning. Asking about the main peak, and it answers accordingly. Asking to classify between two options, and it provides an explanation to each. With this model, we expect to aid workers in the industry better comprehend the reasonings behind the diagnosis process and thus reduce its overall error. Also, the classification provided by the machine learning algorithms in the software can be further explained and confirmed by the model.